Okay, welcome to another freshman engineering seminar. We're going to start right on time each week. As a reminder, if you didn't sign in the back, you definitely need to do that. It says on the syllabus for the course that your attendance is included in your calculation of the grades, and if you're late to class, 2 lates counts as an absence. And so it's really to your benefit to be here on time. And also, I'm sure you've noticed how noisy those doors are as they slam shut, so it's also important to allow our speakers to maintain their focus that you arrive on time. I said that I'm going to put an engineering marvel on screen just as a kickoff slide each week, and this is a picture of the CN Tower, which is a really large structure. When it was built, it was the largest in the world, but it's since been surpassed. It was built in 1976. It's 1,815 feet tall, and I don't know, I just think it's kind of beautiful. I think that it would be a little bit scary to go out on the ledge and do the tour like these folks are doing. Even scarier if you didn't have the restraints, but maybe someday one of us will have the chance to go take a look at that in Toronto. Let's go through a couple of announcements before we introduce our speakers for today. The first is that the Concrete Canoe team is going to be having a meeting at 6 p.m. on Tuesday, September 9th. And I was glad to hear that a lot of freshmen showed up for the first ASCE, SAME student chapter meeting of the semester. So that's good that some of you are starting to get involved, and it's not too late if you do want to get involved, but you missed that first meeting. You can definitely show up, and I'm sure they'd be happy to have your help. Those concrete canoes are heavy. They could definitely use a lot of help to lift them and build them. The other announcement to make is that Huntington Steel is participating in Steel Day, and that's a tour of their facilities. I think they provide some food and give a little bit of an overview of what they do at Huntington Steel. That is from 11 a.m. to 2 p.m. on a Friday, and you know because you're here right now that we have class at noon on Friday. So there's a group that's going to be leaving the engineering lab building at 10:45 on Friday the 19th. And you can go over there and get a taste of Steel Day and be back in time for our class at 12. You won't be able to stay for the whole 3 hours, but if you're interested, I encourage you to join that group of students who will be going on the Steel Day tour. Another announcement is the online quiz. I looked, and just about everybody has completed the quiz 1 as of 11 o'clock today when that quiz closed. It's supposed to be really easy, multiple choice quiz. The main purpose of offering it is just to give you some additional credit for paying attention during the presentations each week. So if you even pay attention a little bit, I hope that you'll be able to answer those easy multiple choice questions without any trouble at all. The next quiz will be open through 11 o'clock next week. So September 12th at 11 o'clock is when that closes. We're going to start following the pattern of a faculty member introduction followed by a main speaker. I'd like you to get acquainted with the professors that you're going to be learning from over the coming years while you're at Marshall. And so to kick that off, our first faculty introduction is going to be Professor Jeff Huffman. And after he gives you an overview of his background and interests, then we'll launch directly into our main speaker for the day, which is Sean Carter. And he comes to give us an overview of the U.S. Army Corps of Engineers and the work that he's doing there. So, Jeff?
Do we have a clicker, or do I got a keyboard?
No clicker, I'm afraid.
No clicker. High tech, high tech, high tech. Good afternoon.
Good afternoon.
Good afternoon. I'm very good at it. Good afternoon.
Good afternoon.
I want to make sure you're awake to start off with, at least, that's for sure. I am Professor Huffman, and a little tidbit about myself for a few minutes to start with, and then we'll do a little bit about geotechnical engineering, which is my expertise and my specialty that I teach here at Marshall. Professor Huffman's real small because it's a little bit about me. More, I want you to get interested in geotech engineering, possibly as a career in the future. Assistant professor, I'm in EL 110 over in the engineering lab building. You can come by and want to see me, want to ask me any questions about what you see today, that'd be great. My email address, if you want to email me, you can ask some of these guys that are up here that are some of the other guys. I'll answer emails sometimes at midnight. If I'm a cranky and I'm going to work on it, get it done. So I have 25 years of consulting experience as a geotech engineer, so I'm not a classic faculty member like some of them that don't have any practical experience. I come in with a tremendous amount of practical experience in design of all kinds of different structures. You're going to see a few things I have worked on. I've been in R&D at some outfits, and I've been in management at some outfits in multiple states. I've been here at Marshall for 4.5 years, so I came back to university teaching after being out in consulting world for a long time. I thoroughly enjoy teaching. Would never go back to consulting. I'll still participate in it while I'm here, but I'll never go back to it. Courses I teach where you might see me eventually. Geotechnical Engineering is a junior course. That's one of the required courses, so you'll see me there. Civil Engineering Materials, we talk about all civil engineering materials: steel, concrete, aggregates, timber, asphalt. Talk about all those in there. Senior Seminar, a similar class to this, where we bring speakers in and I talk to students about what it's like to work in the real world and things you got to deal with, like timesheets and showing up on time and working late and getting to work on great projects and all that kind of stuff. I deal with the Senior Capstone Design course. I'm the one that leads that experience. Dr. Waite's one of the members that helps with that. A lot of our faculty are members in there and help make that happen. Here again, required course. And Foundation Engineering. That is a senior level class. It is not a required course. It's a follow-up to Geotechnical Engineering. We design foundations and retaining walls and slope stability projects and things of that nature. I have taught the CAD lab portion of geomatics. I'm not currently doing that. And I have taught the introduction to CAD that you guys are all taking as freshmen. I currently don't teach that. I am involved in a lot of different organizations. I'm the faculty advisor for the ASCE student chapter. All the freshmen who attended the meeting last night, please stand up. Please stand up. We had 10 or 11 freshmen at last night's meeting. We've never had more than 3 freshmen at a meeting. Did everybody have fun?
Yes.
Did you learn a lot of good stuff?
Yes.
You learned a lot of the advantages that come into those meetings about making contacts and finding jobs, right?
Yes.
We had a bunch of people who got some fantabulous jobs because they're a member and made those connections. So if anybody has any questions what it was like, ask one of these folks. And I encourage all of you to bring at least one person with you next time. And maybe we'll have to have our meetings in here so we have enough chairs or something like that. So thanks, guys. You can sit down. So that's here at the university. I'm also the vice president of the West Virginia section of ASCE. It's one of the parent organizations of our student chapter. I'm also a board member for the SAME Huntington Post. Here again, one of the parent chapters for our student chapter. And I'm also on the Grading Fields Committee here at the university. So those are the things I spend a lot of extra time on. Personally, I'm a native of St. Albans, West Virginia. I'm a West Virginia native, but I've lived in Pennsylvania, Virginia, Tennessee, and I lived part-time in North Carolina. I actually lived for a year, 3 days a week here, 4 days a week here, and I lived 3 or 4 days a week in North Carolina. Running 2 different operations for a company, so crazy. Been married for 25 years. I have one son. He's studying material science and engineering down at Virginia Tech. And I have 2 dogs. And they outweigh me in importance at home. They're more important than me at the house right now. My wife loves the dogs and takes care of them big time. So that's a little bit about me real quick. What I want to get you guys some exposure to is geotechnical engineering. What is geotechnical engineering? The geo, people have all kinds of things about what geo is. They think it's rock and things of that nature. Geotechnical engineers deal with soil. We deal with the strength of soil. How strong is the soil? How big does the foundation need to be? How steep can I make a slope? How big does this dam need to be? So it's all about the strength of the soil, not about growing crops or anything of that nature. When we look at what geotechs do, they deal with foundation systems, shallow foundations and deep foundations. And I got some pictures I'll show you to bring those home for you. The bigger the building, the deeper the foundation has to be in the ground. We deal with slope stability and landslides. We typically try to prevent them from happening up front, but I do a lot of my consulting work on failures that have occurred and how to fix them. Deal with earth dams, making the slopes the correct shape so that the dam works and doesn't fail when the water goes up and down in the structure over time. We deal with retaining walls, small retaining walls, big retaining walls, tied back retaining walls. Here, I got pictures for all these to get you enlightened and want to be a geotech really, really bad. We work on tunnels. Tunnels in the ground. Not all tunnels are in rock. When they're in rock, it makes it maybe a little simpler, but when they're in soil, we have challenges in making a support system to support the earth as the tunnel goes through. We work with what's called engineered fills. Anytime we place a large quantity of soil, we're the ones that control how that's placed and make sure it's done right. If it's not done right, then we're going to have a potential failure down the line. And we deal a lot with road applications. We deal a lot with bridges, roadways, things like that. We don't lay them out, figure out how they lay on the roads or how the turns are or anything of that nature, but we design how thick the different aspects of the road are. And of course, a lot of that's a function of the soil. Everything that's built touches soil somehow, right? Everything, that old adage, foundation is the most important part of anything. That's really, really true. So let me show you some quick photographs of some of these different things. Everybody recognize that? Scoreboard down to the football field. There's deep foundations underneath this thing holding this up. I know there are deep foundations underneath of it. I designed the foundations for that. So if the scoreboard ever falls over, you won't be able to find me because I'll be leaving town. I don't want to be embarrassed. So it has a deep foundation system. Anybody recognize that building? Brand new building. You guys are going to be some of the first students ever in that thing. That thing is just fabulous. And what you see coming out the bottom here is a representation of the deep foundations that are underneath that building. That building's very big, very large, very tall. A lot of brick. Makes it very challenging to make things stable. And those are all the drilled shafts that are underneath that building that hold it up so it'll be there forever and ever. So we can all come back 30 years from now, tell our grandkids, I took classes in this nice big one. Yes, sir.
What are the foundations made of?
This particular one's actually made out of concrete. A lot of times they can be steel, they can be timber, and there can be a lot of different things like that. Good question. Good question. These are some shallow foundations going in. A shallow foundation is typically something that's not deep in the ground, maybe 5 or 6 feet in the ground at the most, and we spread out the foundation, the building loads, so that the soil can carry the strength is enough to carry the loads. We work on slope stability. We try to prevent these things from occurring up front. But geotechs design how steep that can be to prevent this. Once it's happened, then we go out and figure out how to repair it. Slope stability failure, really just, see that's kind of hard to drive across, so we'll come in there. We can design it so it doesn't occur to start with, or we can come back in and repair it afterwards. Now there's pretty good slope stability problem. This is actually in the state of West Virginia, and the day before, I was supposed to have a drill rig sitting about right here on that hillside. They didn't get there in time. I got there early the next morning, called them on the phone, said, guys, no use in coming up, it's already gone. And so we had to do some extra crazy work to get on that slope to actually fix it. We deal with dams, design the slopes, control how much water goes underneath of it. This is a repair structure where they're repairing the dam so it'll hold water better. That's Seeger's Dam of Pennsylvania. That was the big first dam I worked on. I spent 2 years on that project, actually helped in the field on constructing it. There's actually, of course you can't see it, there's actually an old dam submerged right here. It was in such a bad condition that we elected to replace the whole structure as opposed to try to repair the old one. Rock Lake Dam, I'm currently working on that structure right now. It's a side consulting project. That dam, if the rains come like they could, will have water flowing over top of it 4.6 feet tall. That's not what you want to happen to your dam. So we're in the process of retrofitting that so it can take those kind of rain loads. We do retaining walls to make grade changes. This is a soldier pile and lagging wall. These are actually anchors that can go back in the ground, and they can go back in the ground 100 feet. And all that is to help make things stable. We do tunnels. It's hard to show a real good picture of a tunnel because all you can do to take a picture of a tunnel is the entrance to the tunnel. But we do tunnels and design all the structure to make sure that they're stable. Things we try to prevent. We try to prevent things like this, Leaning Tower Pisa. That's a soils foundation problem. It's got weak soil on one side, strong soil on the other side, and that's what makes it have its lean. We try to keep retaining walls from falling over. We try to keep buildings from cracking. This is due to poor foundation design. This one corner of this structure's got incorrectly sized foundation, so that the soil's not strong enough to hold it up, so it starts sinking in the ground. The rest of the structure stays where it's at, and that's why you see that corner dropping down. Earthquakes. We do deal with earthquakes. This was due to liquefaction in 64, and all those buildings had to be replaced because the soil was in a certain state. When the earthquake came, they had no strength whatsoever. Strength went to essentially zero inside the soil. You think you had a bad day at work, and you come home and find out you really had a bad day, right? One of our jobs as geotechnics is to make sure people don't build houses over top sinkholes. Or if they do, that we build them so they can withstand it. There's not much you can do there. Just move on to the next piece of property. So that's real quick. A lot of the things that we do in geotech, it's all about soils and strength. Very unique field, and it's new from an engineering standpoint. It's only about 75, 80 years old from a real scientific rigor understanding. And it's very challenging. There's a lot of art in geotech engineering where we don't have as many standards we have to abide by. It's a lot of just hard work and experience to make geotech problems work. So don't want to take all Sean's time, but anybody got one or two quick questions or anything like that? If you do, come by and see me. My door is always open. It's always open. And we'll get Mr. Carter up here. Am I supposed to introduce him or anything?
Go ahead.
This is Sean Carter, good friend of mine. He works over at the Army Corps of Engineers. Probably seen this building downtown. Sean's been working for the Corps for
15
years. As you'll see in his title, of course he doesn't have it on here, he's one of the chiefs over there. He's one of the people that's responsible for multiple people, multiple projects over there. So he's very, very well connected over there, very knowledgeable about what goes on over there. Today he's going to talk about some of the projects he's done and seen and been involved with over there, and talk about some of the positions they're going to have for interns. All those people that came to the SAMD ASC meeting know how important it can be to get some of those intern jobs. So you want to make sure you pay attention, and if you're interested in it, fly in there, see if you can get one of them. So, and I'll let him introduce everything else about himself.
Thank you. Good afternoon. Man, you got them trained well, Jeff.
We'll get them there.
Nice job. It's a pleasure to be here today. And I don't know about you guys, but I'm pretty pumped about that presentation on the geotech engineering. You can see I work in geotech and water.
He's a geotech.
I'm a geotechnical engineer myself by education and experience. We merged the water resources and geotechnical branches in the Corps. I'll explain a little bit about that, but I'm a geotechnical engineer. I'm still learning about water. I really like the water guys. They work hard. I don't understand everything that goes on, but I'm learning. That's the one thing that I'll try to emphasize about engineering. It's continuous learning. You probably hear that a lot through your school career, and it's definitely true. And I'd kind of like to keep this informal. If you have questions, just speak up or raise your hand and ask me any questions that may come to mind as we go through it. This is a little bit about me. I graduated from Iron High School back in 1991, probably a long time before some of you guys were born. I don't know. I'm still adjusting to being the old guy around, so it's finally starting to hit me now. I went to Ohio State, graduated in March of 1996, and I don't have a lot of pictures through this presentation of my early career, and I was realizing as I was making it, we didn't have digital cameras back then, so I couldn't locate the pictures and scan them in. So I graduated from there in 1996, and then the one thing you also hear through college a lot is don't put off the EIT or PE, and every speaker you probably have will emphasize that, so I'm going to re-emphasize it. Don't put that off. It's not too hard to do the math. I put it off 3 years longer than I had to, and I would recommend doing it right after 4 years. Didn't have any problems with it, but we've got some folks now who are just outstanding, but they've gotten specialized, so it's very, very difficult to go back and take that test. We have some folks my age that have been at it 20 years, and they try to go back and take it, and they fail because they just they've lost touch on a lot of the other specialties. They're so focused right now. I went back to Virginia Tech, got a master's, science and civil engineering, focused on geotechnical engineering. I finished that up in 2006. And that's where I was going to kind of put in a plug for the Corps 2. That was headquarters-sponsored long-term training, which I got funded out of Washington, D.C. at the headquarters level. And they paid for my salary while I went to school. They paid for my books, travel, all that kind of stuff. So it's a great opportunity. It's something we do occasionally at the Corps. We don't send hordes of people off for this, but I was able to send a H&H engineer just to show that I'm unbiased between Geotech and H&H. We sent a guy out to Colorado State this year to get his master's degree. A Marshall grad, Nick Kasunas. So he's off to Colorado State right now. He traveled a couple weeks ago. So I was kind of trying to think about the incoming freshmen really on this, and some of the thought process for me when I kind of stepped back and thought, why did I become an engineer? I made up my mind a little bit early. I think it was in the 7th grade. We had a career fair. Somebody came in to speak with us, and I just thought, man, that's some cool stuff. You know, I'm pretty curious about that. And at that point in time, I thought, well, I better buckle down in my math and sciences. So I did that. And the other thing that really appealed to me was being able to be outside as a civil engineer. I think we might have all mechanical, electrical. Is it mainly civil?
There's 40 plus mechanicals in there right now.
Okay. So mechanical engineers, mine's going to be focused more on civil. But that was one of the things that kind of really appealed to me at that time, and I stuck with it. You know, got some doubters and things in high school, and maybe I goofed off a little bit, but made it through, buckled down in college. You got to remember what your priorities are, and what you do during that time is going to have a big impact on how the rest of your life goes. So you want to stay serious about it. One of the other things I was kind of thinking as I was putting this together, and I thought, what are some good engineering traits, or maybe some of these are essential, but also temper this by this is just my opinion. You guys will hear a lot of opinions from a lot of folks, and take what advice suits you. But observant, most engineers are pretty observant, trying to look at things, figure out how they work. Curious, thorough, analytical, and the one I wanted to throw in was communication skills. You can be a genius, but if you can't communicate your ideas or kind of sell it to a client or explain why you think the way you do, it's not worth a whole lot. So research and the continuous learning, that's another big one. Team player. I think in just about any project I've been involved with, it was always a team. When I was in private sector, I was working with other consultants that were tasking me for geotech and had to be able to communicate that. So wherever you work, it's most likely going to be a team. And civil engineers, we want to ensure public trust. So that's one thing you should be interested in. When they drive across the bridges, when the foundations, the landslides, the highways, they're trusting us to design good infrastructure for them to use on a daily basis. And it can have catastrophic results if we don't do due diligence. The other thing I was going to kind of stress too is one of the traits is balance. You got to have some balance between your personal and professional life. In my career, 20 years, I've seen people that swayed too much one way or too much the other. But it's important to make time for those things that are important to you, whether it's the dogs at home and I had a dog for 14 years and spent a lot of time with him, especially when I was off getting my master's. My family kind of abandoned me a little bit that year, so I spent a lot of time with my dog, Old Blue. But make time to get out and spend time with the family. Golf, motorcycles, whatever is important to you. So then I was kind of thinking, well, the transition from school to work. I started out with a consultant. The market wasn't real great when I got out of school, and I was kind of filling things out here in I'd say in the region before I was ready to go out west or up north or far down south. And I got on with a consultant as a technician, field technician. So my job for the first year was testing soil compaction. That's what this guy's doing right here with the nuclear density gauge. He's out on that engineered field, making sure that the moisture and the compaction are appropriate for that job. Doing footing inspections, what you see in the upper right there. and arguing with contractors. If you find unsuitable bearing material and they've already put in their forms and the reinforcement steel, it's really hard to persuade them to take it out and dig a little deeper. But you got to stand strong sometimes and do the right thing, even if you got to kind of stand toe-to-toe with a contractor. A lot of good ones, some bad ones. One thing is dealing with developers. I hope nobody has to do that in their career, but it's just one of the facts of life, and it's kind of tough sometimes. Test and slump, air entrainment, concrete, yields, things of that nature, and doing boring inspection in the lower right over there. So kind of the emphasis on this, I mean, when I got out of college, I didn't really care about the dollars too much. I just wanted to be in the middle of something. I wanted to be out there learning, be on a project, doing things, and that was my attitude. It's worked well for me over the course of my career. I definitely wasn't bragging about how much I made when I first started out, because in 1996 dollars, I started out at $6.50 an hour. And then when my paperwork went through corporate, they learned I was an engineer and gave me $1 an hour raise. So I was making $7.50 an hour. But I was happy just doing it, and I just wanted to get the experience, and the money part took care of itself. Because when you're out there working, doing a good job, your supervisors and the other people in the company, they'll definitely notice that. So I didn't think any job wasn't beneath me at that point. I spent days just moving concrete test cylinders out of the curing room and breaking cylinders and prepping rock core for unconfines and things of that nature. And then after about a year or so of that, I started getting into some geotechnical engineering. This company at the time, you really didn't practice too much as a geotechnical engineer unless you had a master's degree. But fortunately for me, they couldn't attract too many geotechnical engineers in Charleston, West Virginia at that point in time, so they kind of gave me a crack at it. It required a lot of independent study for me in the evenings to get prepped up for each job. I did that on my own time to try to learn what to do, and had some good mentors to kind of show me the way. But my goal was always to go back to graduate school, which I finally did. So I might have jumped ahead a little bit, but the work experience, I kind of got my start in what I'm going to show you guys here in a little bit, was working as an engineering aide for 2 summers at the Huntington District Corps of Engineers. That was back in 1994 and 1995. I happened to be walking through the career office at Ohio State and saw something on the wall that said, Corps of Engineers, Huntington District, what's that and where is it? So I got to looking into it a little more, put in an application, fortunate enough to get the position, and really liked what I was doing at the time. At that point in time, we were building a new lock similar to what you see in the picture there. That's the Marmet one that we did between 02 and 09, but we also did a lock replacement at Winfield in the mid-90s. So I got to be out and see some of that. Worked with the soils and geotech folks there. Worked on the West Virginia Ordnance Works up around Point Pleasant. Out there doing some sampling, looking at the embankments they did. They're kind of low-head dikes and dams and things around there. But just kind of started getting excited about it, and that was really what got me wanting to go into geotech as a specialty. There was a federal hiring freeze when I graduated school. I was pretty close to getting on there permanent, but they sent me out into the consulting world for a while. HC Nutting Company up in Charleston, I worked from 96 to 2000, and I tell you what, I just got experience in every aspect of construction, really. I tested fireproofing at the Embassy Suites in Charleston. I was on building construction up University of Charleston. I mean, I was doing cell phones. The foundations Jeff was talking about for the scoreboard, I did similar things on the cell phones. Cell phones were just coming around too. I actually had a bag phone about this big in my vehicle with an antenna, you know, magnet antenna up on the top, which I could use on occasion, but you didn't use them too much back then, mainly in an emergency situation or something, because it got pretty pricey. So that was great experience, and by the end of that, I was doing a lot of landslide remediation, deep and shallow foundation design, those types of things, and then I started with the Corps in 2000. And for the first 10 years of my career with the Corps, I worked as a geotech engineer. I'll show you a few pictures later, but I was doing streambank erosion protection, where like the Kanawha River is eroding back under Kanawha Boulevard, and we want to protect that. the big floods in '01, '02, '03, and '04 down to southern West Virginia, we executed about $30 million, I think, restoring some of the roads down there and putting all the limestone on the banks that you see. The one other thing I'll add is I graduated from Ohio State, but my parents are both Marshall alumni. Marshall did not have an engineering program when I was at that point in time, or I would have probably came here. I think I'll probably have a couple kids at Marshall. So let me jump to the Huntington District. Was there anybody in this room that really didn't know about the Huntington District or the Corps of Engineers before this? Yeah, I didn't know much either when I was your age. I mean, I kind of knew the granite block and dam was there. Being from Ironton, I went fishing downstream of it, knew there was hydropower, but I knew barges went up and down the river, but I just never really thought about it that much. Well, the Huntington District was formed in 1922, so it's been around quite a while. I think the original office was up in Wheeling, and we also had an office up in Zanesville, Ohio, when we were constructing up there. So it all came together right here in Huntington. And some of this I kind of stole from one of the commander's briefings they'd put together to kind of show you some nice things. And responsible for locks 12 through 32 and making the Ohio River navigable. Constructed the first high lift navigation. And really the point of this one I was going to show was the 1937 flood. Had a huge impact on the region. And really for us, we act at the direction of Congress. They have to authorize us for a project or a program or anything we do. And authorization's great, but you really can't do anything unless you get the appropriations. So we got to have money to go along with that. There's a lot of things we're authorized and mandated and regulated to do, but without funding to go with it, it doesn't really amount to a whole lot. So after the 37 flood, they got busy. They got the authorization, they got the appropriations, and we built a system of flood risk management projects here in our district. I'll show you the boundaries and things. The other big thing was the 77 flood down in southern West Virginia at Tugwell-Vizard Forks. 202 authorization, and that's a lot of the flood proofing, house raising, doing things on individual structures. You've probably driven down through there and seen a lot of houses up with the vents on either side so the water can flow through, and so that was us doing those types of things. There's kind of an overview of the district. Some folks don't realize just how big it is, 45,000 square miles. It's from Akron, Ohio, down to Boone, North Carolina. Yeah, we got a question? A lock? It basically, what we do is we guarantee a 9-foot depth in the rivers at all times, and that's the draft for the barges to go up and down the river. So what we've done, and I wish I would have had that slide, was we built a series of dams up the Ohio River so the barge can come in on a flat pool where it's shallowing down to 9, and then we'll bring them in the chamber. Well, there's no pumps or anything. We basically just use gravity, open some culverts, and flood it from the upstream side, lift him up, and typical lift is about 22 to 24 feet. So we'll lift him up, and then he can go on through the next pool. But in Huntington, we've got 9 locks and dams. We've got them on the Ohio River from Willow Islands up around Parkersburg, and then we've got Captain Anthony Meldal down at Cincinnati. And then we've got, of course, R.C. Bird backs up on the Kanawha, and then Winfield, Marmet, and London's furthest upstream. But that's kind of what that's all about. So we go out and we also dredge downstream of those locks to make sure we maintain that minimum depth. And that's one of our big missions is navigation. So that kind of gives you an overview. There are 35 lakes, just what I'd call flood risk management or flood damage reduction projects. Sole purpose is to scalp the top off that hydrograph so we don't flood people downstream. 29 local protection projects like the levee flood wall here in Huntington. I think that was completed around 1950. That was also a reaction from that 37 event. And those were built by the federal government in cooperation with the local sponsor, Huntington, but then we turn it over to them to operate and maintain in perpetuity. But if there's a failure of any type or they need technical advice, they come back to us. So we do have a group that helps those folks out. 773 employees in Huntington right now, and our funding for this year is $215.2 million. So that's kind of what's coming through Huntington for us to maintain our emissions. We're actually doing a project down in Boone, North Carolina at Appy State right now, which is a natural stream restoration project. So we do things all over this geographic area. And if you wonder why it's such an oddball boundary, is we're capturing everything that flows into the river between the Meldal, which you can see, let's point it out. That's the Meldal, the furthest downstream locking dam, and then Willow Island, which is our furthest upstream. We catch everything that flows into the river between those 2 points. The other point I'll make on the locks and dams on the river is they don't have any benefit when it comes to flood control. They just pass the flood. We roll our gates totally up out of the water, flows right on down. Question?
Just curious, when's the last time the walls here in Huntington have been closed up?
I think they did it once, but they didn't get loaded, but 97 was the last big Ohio River flood that we had around here. And during that time, I was working in Charleston, still living in Ironton, and I remember one lane I-64 at Cabell Midland was flooded with water at that time, one of the eastbound lanes. And of course, there was a lot of places flooded out there, but that was the last big one. I think we've had a couple high water events in the 04 when Hurricane Ivan came through. We got pretty high, and they may have installed a couple gates. I don't think anything got water on it. What they have for their operations is triggers. When the river level gets to this point and it's still rising, they know to go out and put gates in at certain streets and things and close gate wells so we don't back flood and all those kind of things. This was just kind of a little snapshot of the U.S. showing the Corps of Engineers projects. And the point of this one, what I was going to show was we're kind of in the Appalachian region. Flooding is one of the natural disasters we have. So we've tried to mitigate that with our projects, and you can see a really high concentration of projects there. Over in the Ozarks and around that area, you see another high concentration. Out west, you don't see a whole lot from the Corps. The Bureau of Reclamation has a lot of projects out there, and they're for conservation of water. This was kind of overlaid with the drought as it stood in February of this year. I don't think things have got a whole lot better out in California and out west, but I kind of stole this one. The purpose of it was, where's the risk lie, and folks wanting us to impound more water for conservation. Yes?
So on that previous map, is there only one office for that whole district?
That is correct. Our headquarters is right here in Huntington. We do have field offices, but those are like for regulatory. We permit the mountaintop removal, coal mines. We have construction offices and other field offices. We also have area offices, like we're split up by basin. So one up in Columbus for the Scioto Basin, one in Summersville for the Kanawha Basin, one up in Dover, Ohio for the Muskingum Basin. So we've got some more small offices, but I think maybe close to 500 of those 773 folks are housed here in Huntington. Some of the benefits, I won't read off all this, but just kind of let you know what kind of impact the Corps has nationally. So 90% of the exports move through waterways that we provide navigation on. We're the 5th largest electricity producer because we do have hydropower at a lot of our projects. Our most recent ones are Willow Island and at Parkersburg, the Meldal down by Cincinnati. They're installing hydropower in those right now. Should be operational within the next 6 months, I believe. So those are big plants. We don't do that. We just allow folks to do that onto our projects. It's actually AMP Ohio's the developer, but each one of those is like 500 million plus for construction each. But we're concerned from a dam safety perspective. If we lose our pool, navigation goes down on the Ohio, not good. So there's some other facts and figures. I'll kind of show you a little bit of the same, but this is more geared towards Huntington. It's like, who cares? What's the value to the nation? So this just kind of shows you some of that. The red is our numbers. So 2.2 billion tons of commodities that go through our locks and dams, and I think it was calendar year 12. Recreation, we get 370 million visitors at our projects here in the Huntington District. Flood risk management, there's 702 dams nationwide. We have 35 of those, and they've mitigated $12.2 billion worth of damage to date. So they've got a really high benefit to cost ratio. Overseas contingency operations, we send folks over to Iraq, Afghanistan for the construction over there. You can see how many we've had. We got 6 over there right now. Work for others. We do a lot of things for other federal agencies, Department of Energy and Veterans Affairs, all that kind of stuff. Emergency operations, anytime, like some folks from southern West Virginia may have seen some of the, like the temporary housing we put in. We did Taylorsville along Corridor G after the 04 flood was when we did that. And when folks get displaced, we jump in, we go down, we put in the infrastructure, the sewage package plants, the electricity, the water, all that kind of stuff for FEMA. They task us and we'll build those. So we got our hands in a lot of things that people might not think that we're into there. I'm not going to spend much time on this. I just kind of wanted to show you the breakdown. And I'll kind of focus on engineering construction, the second one down. It's 150 folks that we have in engineering and construction in Huntington. Our operations folks are wage grade. We got welders, we got maintenance workers, we got resource managers, we got rangers. They're by far the biggest entity in the Huntington District, but just kind of want to show you the breakdown so you can understand. I won't go into many details, but I will mention I think it's the 5th one down there where it says DSPC MCX. That's the Dam Safety Production Center and Mandatory Center of Expertise for the entire nation is housed here in Huntington. We had so much expertise that we competed nationwide and we're able to secure that here. So we've got a group of folks that are at 30 right now. Full force would be about 60 people, and they're developing national guidance for the Corps dam safety and working throughout the region and the country on dam safety projects, mitigation. And 2 of the positions I'm going to show in a little while are with the Dam Safety Production Center. So this is kind of a breakdown. My understanding is that this is going to be available to you. I'm not going to go through all this, but it kind of gives you a flavor of the kind of folks that we have in engineering construction. Of course, we got civil engineers, we got mechanical engineers, we got electrical engineers, and we got a lot of support staff, a lot of technicians, materials engineers, laboratory technicians. We kind of run the full gamut on engineering, really. We've got environmental engineers, geologists, engineering technology specialists. Yes? Yeah, we do have computer science engineers. As far as just systems and working on systems and things, that one's it's kind of strange. It's headquartered out of Vicksburg, and there's a group of about 16 folks in Huntington that maintain all our computer systems. In water resources, without going into too much detail, we've got a gauging system that works through satellites and transmits precipitation data. We've also got lake pool elevations. We've got river stage elevations. It's a working system that transmits all back to our water managers in Huntington, and they'll actually model our all 45,000 square miles every day, see how things are going. And that keeps the models calibrated, so when we get in a flood stage, you know, it's just like clockwork, and we can do forecasting, things of that. But we've got 3 IT, computer science type folks working there that keep that system up and running. They're writing script, code, doing all that type of thing. They stay pretty busy. So there's kind of the branches. Geotech and Water Resources, me, construction and HTRW. A lot of these are field folks. They're down at Bluestone working on that dam. They're up in Muskingum working on dams. They're all over the place. And we have design engineering branch. That's where it houses our electrical, mechanical. That's kind of a big thing now with our pump stations and all the infrastructure we have is getting very, very old. So they're trying to retrofit, upgrade our gates for our dams need replaced, the electric motors, the control panel, switchboards, all that kind of stuff they work on. Another big one's cost engineering. We got a group of maybe 15 cost engineers. They develop the independent government estimates. They do a lot of work for the Department of Energy and others. So I didn't know how many folks have thought about that, but there's a need for us right there. And then all the support functions. Here's the employment opportunities we have coming out now. Department of the DA interns is what we call them. They're hired through the Department of the Army. They actually come through headquarters, so they're funded through DC, but they work for us. They take their direction from us, but we don't pay anything for them. We get them free for 2 years to test them out. So it's a great opportunity for us to see if it's a good fit for you, a good fit for us. We've been hiring under that program. You can see we got actually 4 civil engineers. We're looking for 2 that are interested in structural engineering, doing the steel, the concrete, that kind of thing. 1 cost engineer and 1 H&H engineer. Oh, hydraulics and hydrology. They're the water managers doing the modeling. They also set elevations and design new projects. Right now we've got 3 what we call H&H engineers that help on the initial design and project stage, and we've got about 7 water managers, which are still H&H engineers, but they do our daily operations. So we're expecting recruitment to begin around January, February next year. Yes? You can check it if you do opm.gov, and it's just, if you just do a GS pay schedule, you'd probably come in as a GS3. I'm not sure what it is right now, but you can look at it. It'd be a GS2 or 3, step 1 is what you come in as. All our pay schedules are published out there. Everybody knows what everybody makes, so there's no secrets to that in the government. And I've heard a rumor that we might get a 1% raise this year. So those are some good positions. It'd be recruiting then, and we could definitely, it could be somebody start after graduation. We definitely have that much time. So we can be flexible on a start date, but we'll be starting to look at applications and things. The other thing I wanted to emphasize, usajobs.gov. Go out there, get yourself an account if you're interested, and you can also set triggers, so it'll send you emails, and you'll see these job announcements pop up. It'll send you an email, see if you're interested. This is not only Department of the Army or Corps of Engineers, but Veterans Affairs and Bureau of Rec. Any government agency is going to show up on there as well. But any hiring we do has to go through usajobs.gov. It's not the good old days where we can look through a stack of resumes and just pick one anymore. And then on the lower part, it's called Pathways, just in case anybody wants to research, but it's basically, when I hired on it was called an engineering aid. So what we'd be looking at there is we got 6 positions, and we'd be looking for 20 to 25 hours a week during the school year that you could work anytime between 7 and 5:30 or 6 p.m. And then of course we'd expect full time in the summer, maybe even some overtime. And we're looking for 4 of those in geotechnical oriented. 2 of those are in the Dam Safety Production Center. 2 of them are in the Huntington District or in my branch. So those could be civil engineers with geotech interest or geologists. And one that's interested in cost, and then geospatial. I didn't know if we had any in this crowd, but that one's pretty flexible if they just have that interest in GIS and geospatial type things. So I'm going to run through this. I'm running long. There's a couple things we worked on. When you're driving I-64, we protected Kanawha Boulevard up in Charleston. But I was going to give you a backstory on this guy. He wasn't too happy when he saw it, but he's getting happy when he sees the Marmet lock replacement. We replaced 2 twin chambers, as I was talking about before, with 1 big chamber, so you can reconfigure the toes. You can do a 3x3, 3 long and 3 wide, and get 9 through at a time. versus the old one where they were doing one by one. And then I was going to get into dam safety a little bit, but maybe I can dog it off. If anybody, I would just offer, I know people are on schedules and things. If anybody, I'll defer to you guys on the schedule, but if anybody has to get up and leave, have another commitment, they can get up and leave without embarrassment. If anybody wants to hear the next 4 or 5 slides, I'd be happy to stick around and talk some more. Yeah. I could film and get.
Oh yeah, they know how to tell time. And some of them you can't blame them because some of them they may have to.
Oh yeah.
Get almost to their end of campus and get settled and stuff.
Get them some lunch.
Yeah. I didn't know you had the DA intern that's coming on. I know.
I guess I'm still recording.
Oh, you might get it. That's cool. I wasn't worthy of recording. You can tell.
No, that was a great job.
It's got the whiz bangs, the photos is what gets them, there's failures and all that stuff. I do the same thing. My first lecture is going over syllabus and introductions, and usually we end up talking, because usually by that time they're juniors. I know who they are, and I know what kind of experiences they had over the summer and that kind of thing, and then the rest of the class is just showing pictures of Terzaghi all the way through Duncan and all that stuff, and then just showing photographs of all disasters. Well, it looks like you have a small group.
Okay. Well, thanks for sticking around, those whose schedule allowed. I'll go ahead and go through the rest of these. What I've been concerned about for the last 10 or so years is dam safety. Hopefully a lot of people have heard about Teton Dam. It was out in Idaho, and that was a real wake-up call for the dam safety community, and really got a lot of things spurred along with that authorization and appropriations for a dam safety program. And then I kind of showed the other one, Lake Delhi, Iowa. They actually had a dam failure back in 2010, so stuff still happens. Things still go wrong. It's really hard to figure all the things that could go on. The Lake Delhi, the reason it failed are the spillway got blocked with debris and the embankment got overtopped and scoured. But I was going to just try to give you an overview of what we're concerned about as geotechnical engineers. Jeff kind of touched on it, but this is one of the dams that I've spent 10 years working on up in Ohio. It's an 87-foot tall embankment. It's 6,000 feet long. It stores a lot of water. It's actually a dry dam normally, but when we have a flood event, we can shut the gates, hold the water back. But what we found is this is glacial outwash out there. It's built on up to 200 feet of sand and gravel. So you get a whole lot of seepage under it. And seepage is not necessarily a bad thing, but when it starts backward eroding, piping the material out, it's a very bad thing. And that's what we're trying to guard against here. You can kind of see how the seepage is kind of coming out of there, and we're worried about these types of things downstream, because what you can do is propagate a pipe from here that if it can hold a roof, it can tap into your pool, and then you'll have a gross enlargement and the dam will collapse, and that's how most dam failures occur, seepage and piping. So I just want to give you a little flavor of some of the things we do. This was a model I ran with. This was actually the slope stability run. We use a GeoStudio software package, and what we do is set all the boundary conditions. We calibrate for all the piezometers there. If you don't know what a piezometer is, it's basically just a PVC rod down in the ground with a porous tip on it, and we can measure what the water pressure is down at that elevation. So you can see they have variable elevations, variable distances, and we'll calibrate our seepage model with what we're getting out of those readings. So then we can import all those pore pressures into a slope stability model and see what we're getting for factors of safety. You can see that one's not too good. 0.3 is not acceptable. I think we were shooting for a 1.25. Well, we're actually building something on this one. I didn't bring a slide for it. but we're going to make sure we have our impervious cover up here, and we're going to build a seepage barrier, a 140-foot deep wall from here down to here in the ground. It'll totally be subsurface. Unless you know it's there, you'll never see it. But it's 140 foot deep and 4,000 foot long.
So you just go straight down to bedrock?
This one we're actually not taking to bedrock. That's why we've called it a seepage barrier. But it's socketing down into the alluvial sands that you saw in the last one. We've got a silty sand down deep, and then above that we have what we call open work gravels and poorly graded sands, which transmit a lot more water. So it is a positive cutoff through that upper soil, but we're socketing into some less permeable or conductive soils below.
How wide is that?
3 foot, 3 foot wide, 140 deep, and it's actually 4,400 feet long. And we're also doing a state-of-the-art automated data acquisition system to automate these piezometers so we can get real-time information. We've got relief wells downstream that we're automating those so we can get real-time flow measurements there, and we're putting some inclinometers in the wall so we can try to measure any kind of deflection when it first gets loaded up. So there's a lot more to the story, but that's the key component. We're also building filters on the terrace downstream, seepage berms, but the primary components to cut off are seepage barrier. This was taken last week. That was August 28th. This is a groundbreaking for the seepage barrier. $44 million contract, and we awarded it a few months ago, but this was for the dignitaries and the colonel from Cincinnati to come out. Everybody throw a shovel full of dirt. So pretty exciting time for me, considering I started this project kind of on my own a little bit back in 2003, just out there gathering data, trying to figure out what's going on, talking to the old timers that have been around, just kind of information gathering mode. And of course, the last 4 years I haven't worked on it as a geotechnical engineer. I kind of stepped into management. I'm responsible for about 40, 45 people and budgets and things of that nature, so they kind of keep me busy now. But I worked on it for about 6 years, try to get it off the ground. Pretty exciting time for us. Then I was going to try to tell you another lesson in engineering. When you go out, be ready for anything that might come your way. If it's in the winter time, even if it's warm, you bring your snow gear, bring your hard hat, steel toes, safety vest, safety glass, all that stuff. Anytime you go out or could go on a construction site, leave it in your car. I went up to the same dam for reconnaissance during a high water event. You can see the date there. It was 2008 on the 7th, and it was the first blizzard I've ever been in, but things get pretty nasty pretty fast up north. We got 14 inches of snow that day, shut down the interstates, and I was out there just walking downstream of a dam looking at boils and things. But really fun day, but you want to be prepared for those. That was kind of the life lesson. This was 2 days later, different dam, taking relief well measurements manually downstream, but you kind of see how deep the snow is there. It was a good time. Another thing, have your gear ready anytime you go out in the field. It's better to have it and not need it than the other way around. The other thing, you don't know where your career is going to take you. These were just, I was kind of taking a trip down memory lane preparing this. The one in the upper left, that's Mount Rainier out in Washington. I wanted to see some glacial outwash while I was out there. I went out and took a look, looking at the depositional environment. Yeah, it's a little geeky. I get excited about that stuff. I'm a geotechnical engineer. So we drove up the mountain looking at the glacial runoff. That was during the blizzard over there. That was at a little diner called the Ginger Root, but just a photo op I took advantage of. Had a co-worker who's got his pilot's license. We went up to take a look at Summersville before and after the deep drawdown we did a couple years ago. So I was in the back of the plane just tooling around the lake, looking at things. Pretty fun for me. And then the lower right was, I'd always had an opportunity to go to Southern California for a conference, and I always had an interest in the Salton Sea. I think that's when the Colorado River came out of its dike and filled up a low spot out there. Pretty interesting. But when you hear it's a dry heat, it really doesn't matter much when it's 110. It'll get you. Those were just kind of comic relief. The seepage distress, I was kind of explaining to you. I will try to get through all this, but just the opportunities. I got to go out to the Midwest during the 2008 flood. This is on the White and Wabash rivers out in Indiana, Illinois, right in between those states. And some of these boils are pretty fantastic for a geotechnical engineer. Some angry seepage there. The lower right, I mean, I don't even understand how that levee didn't fail. We're just guessing 1,000 gallons per minute because you kind of get calibrated looking at wells, and when you're doing it a lot, you can see, I mean, that bowl up there, when they're pumping out the sand like that, they're getting pretty mad. And yeah, and some of these, I mean, we would look at some of this and come out the next day and the levee's failed because there's just hundreds of miles of this levee. And one of the reasons, normally, if this was downstream of a dam, lights would be going off. We'd have everybody out there, but these were just protecting ag fields. It was cornfields, so we could tolerate a lot more, let them go a little further than we normally would. So there wasn't any life loss. Public safety is paramount in everything we do. Those are sand boils. What you have is, I may not have a good cross section, but you can kind of see this levee right here. This is actually this boil as you would see it from the top of the levee. It's kind of hard to see with the scum and all the stuff that comes up. And there's maybe a 4 or 5 foot clay cap out there in alluvial environment. Could be thicker, could be thinner, varies. I think around here maybe it's 15, 20 foot a lot of times around Huntington. And then under that you get the alluvial sorting, and you'll have some poorly graded sands, and they'll grade on down to gravel or whatever. But when you get that combination, the water's, it's got a wide open entrance at the riverbank because it's scoured and eroded, and it goes into those sands and gravels. Well, it transmits under the levee, but it doesn't dissipate much energy going through those open graded materials. So then the easiest way to go is up, and it'll actually heave that clay cap up and start seeping, and it starts moving fast enough to pull that sand with it. It's called an exit gradient, but it'll heave that and then pull the sand up with it, and that's what we call a sand boil. And it just kind of boils, and sometimes there's been mega boils for the Mississippi that are 20, 30 foot diameter on some of those big floods. These are big for anything we might see around here. But they might heal themselves. The other thing you do is sandbag them to try to slow the water down so it doesn't have the sediment load. And if you put too much pressure on them, they'll just pop up over here. It's like sticking your finger in a hole in the dam. But you try to find a balance just to stop the material moving. So, but yeah, it's really interesting. And I actually reached my hand down in the boil and could feel the bottom of the clay blanket and feel water coming out underneath. So, neat opportunities. Get to see a lot of things traveling around. This was the same event. This is what I started out on. The Indiana DNR, they're responsible for regulating all the high hazard dams in Indiana. They had two engineers. One was sick and one was on vacation. So the states, they called to FEMA, asked for assistance. FEMA says, hey, Corps of Engineers, go help the state of Indiana. So we got a team of folks, and we went out and we just did initial recon on these dams. Are they safe? Do we need to evacuate downstream? What's the next step? So this is East Princess Lake in Indiana. You see it got overtop. Another one was spillway debris. There it is after the fact. Here's my vantage point when I went out to look at it. And the question is, do you evacuate folks downstream? Kind of a tough call. You got to think about it a little bit. We did not evacuate downstream. It's a homogeneous, impervious embankment. Phreatic levels are dropping off fast. When you look at the entire embankment, what was scoured away is a very, very small percentage of the overall cross section, maybe 5% or something like that. But it looks pretty nasty, pretty dramatic when you get out there and see it. This was just another flood fight we did up in northern Ohio. We had a levee. We had about 3,000 GPM coming out. We decided to build a seepage berm. The point of this one was the communication again. We didn't communicate too good with the public and kind of scared them. This was Easter morning. But there's a picture of Bluestone. open it up for any questions. And the little backstory on this one was the Manhattan Project. Everybody know what that was? Developing the atom bomb. They built two projects for hydropower. They needed a clean energy source. One was Bluestone, one was something else. I can't remember what. The other one got online first. They shut Bluestone down during the war, went ahead and completed it for flood risk management, and never did the hydropower because it's in the middle of coal country. I appreciate your time. It was a pleasure talking with you today. Any questions? One of these guys will have my contact, and feel free, they can forward an email or I can put it out there.
So those student internships, how far along in their studies do you usually want interns to be for their?
We're extremely flexible